All right, in this particular lesson, we're going to be talking about special right triangles. Particularly, we're going to talk about two special right triangles. The first one is called a 45-45-90 triangle. What this means is that in a 45-45-90 triangle, the hypotenuse is the square root of 2 times as long as each side, meaning very simply that when you look at a triangle and the angles are 45, 45, and 90 degrees on the inside of the triangle, we can say that the sides opposite of the 45-degree angles are equal to x, and the side opposite of the 90-degree angle is x times the square root of 2. All right, so for example, all right, so this is just exactly how they figure that out. Okay, using the Pythagorean theorem, you can actually solve this. So in this case, we have x squared plus x squared equals c squared. Okay, so you can see x squared times x squared equals c squared. Combine those two, find the square root, and that's where we get this idea from. So, uh, for example, if this x was equal to 3, then this would be equal to 3. And then this side would actually be equal to 3 times the square root of 2. Okay? All right. So, the second special type of, or special right triangle we're going to be talking about is called a 30-60-90 triangle. Same type of idea applies as the 45-45-90. There are certain, there are particular sides of the triangle that have certain lengths depending on what they're across from. So across from our 30-degree angle, we've got an x. Across from my 60-degree angle, I have an x times the square root of 3. And then across from my 90-degree angle, I have a 2x. All right, and here's just a really long way of looking at how we actually solve this. So don't worry about memorizing this. I'm just showing it to you so you believe me. All right. Okay. So we can actually use this idea to solve for these particular triangles. So if we know we have a 45-degree angle and a 90-degree angle, we can automatically assume that my other angle here is going to be 45 degrees, because 90 plus 45, subtract that from 180, you get 45. Okay, so if I wanted to find my missing sides, I can say, well, opposite 45 is x, and I know opposite of any 45-degree angle is going to be x. So in this case, x equals 7. Okay, now going back to my idea of what this across from the 90-degree angle is, I have to think about, well, it's x times the square root of 2. So in this case, x is 7 times the square root of 2. So it would be 7 times the square root of 2. Okay, so same idea over here. We know we have a 30-degree angle and a 90-degree angle. So I can safely assume that this is going to be a 60-degree angle. Okay, then I have to remember what my rules are. So across from a 30-degree angle is x. All right. Across from a 60-degree angle is x. In this case, is 9 times the square root of, ooh, wrong thing to grab, square root of 3. Okay. And then across from my 90-degree angle, or my hypotenuse, is 9, is 2x. So in this case, 9 times 2, which we know is 18. All right, so it's a very basic idea of how to do this. There's really no tricks when working with this. You just have to basically figure it out, and you'll be able to do it really easily. The whole purpose of knowing that these rules is basically to do exactly what I did here and find unknown lengths. All right, um, and for your um, just for your benefit, so you know, you can leave your answer as 7 times the square root of 2 or 9 times the square root of 3. You do not need to convert that for this in this case. Okay. All right. So come back with any questions, and please make sure you have your notes and your whisk done for me tomorrow. Oh, and if you want to, draw a four-leaf clover. Well, actually, you have to. Draw a four-leaf clover in the corner of your whisk so I know that you watched the entire video. Dun dun dun.